So let's dive into the limit of a function. So how does f of x, x cubed minus 4 x over x plus 2, behave around x equals 2? As the value of x approaches 2 from either side of 2, the values of y equals f of x approach 1. Mathematically, we say that the limit of f of x as x approaches 2 is 1. So symbolically, we would write it. Here's the limit of the function f of x as x approaches 2 equals 1. So this is our limit, 1. So the limit of our function as x approaches 2 equals 1. And if we look at our graph here, okay, so here's 2. There's our 2. As x is approaching 2 from the left, and x approaching 2 from the right, what y value are we getting to? And as you can see, it is 1. So again, we're approaching from the left, approaching from the right, and they both go to 1 when we get to 2. So, intuitively, our definition of a limit: let f of x be a function defined at all values in an open interval containing a, with the possible exception of a itself. Possible. Keep that in mind. There may be an issue at a. And let L be a real number if all values of the function f of x approach the real number L as the values of x, that does not equal a, approach the number a, then we say that the limit of f of x as x approaches a is L. So as x gets closer and closer to a, the function value gets closer and closer and stays close to L. And symbolically, this is an important a symbol to know, as the limit of f of x, or the limit of f of x as x gets closer and closer to a from the left and right, it equals L, whatever that real number may be. It's a real number. So again, we're going to look at the calculators and look at the limit of a particular function, and we're going to round to 8 digits. So you can kind of see the answers here. So here's our limit, x, or the limit of our function, x squared minus 4 over x squared plus x minus 6. So here's our function right here. Here's the limit as x approaches 2. We're going to see what is the limit. So as x gets closer and closer to 2 of this function, what are we getting close to? So again, you can plug it into your calculator. This also can be done algebraically, and we'll talk about that more as well. So looking at this, we have our function in. We're coming from the left, coming from the right, and we're approaching 2. Something happens at 2. Okay, oops, I clicked too soon. Let's go back one. As we're getting closer and closer to 2 from the left and from the right, you can see we're getting close to 0.8. Now at 2, we can't, there's an error, but as the limit approaches 2, you can see they're both getting closer and closer to 0.8. Not equaling, not getting to 2, but it's getting close to 0.8. So 0.8 would be our limit, which is 4/5. Okay, I mentioned that we could do this algebraically, and I want to show you this real quick. So let's look at this same function. What if I wanted to find the limit of this? And so what we're going to do, the first thing you would do is plug 2 in and see what happens. So usually the first thing to do is to plug 2 into the function, and let's see what we get. So if I do 2 squared minus 4, and then I'd have 2 squared plus 2 minus 6, and it looks like I get 4 minus 4, which is 0. And then I have 4 plus 2, which is 6. 6 minus 6 is 0. Oops. There's a problem, okay? The 0 on top was okay, but not down here in the bottom. That's undefined. This is actually an indeterminate form. I'm not sure what this answer is. Could be 0, could be 1, Could be undefined, could be something else. So this doesn't help me at all. So usually you try substitution first. That didn't work. All right. The next thing I would look at, so let's look at this. And you may have already guessed, we can factor the top and bottom, right? X minus 2, x plus 2, that factors x squared minus 4. And let's see if we can factor, see if we can do some, we're going to do some simplifying here. X and x, I have a minus and a plus. Looks like 3 and 2, 3 and 2. And that does help because what happens, I can cancel these out. Okay, so let's go ahead and now try it again. I have x plus 2, so the limit is x plus 2 over x plus 3, or the limit of that function as x approaches 2. We're going to try that direct substitution again. 2 plus 3, which equals 4/5, and that's what we got using a calculator. That is 0.8, which is 4/5. So again, algebraically, we can do it. We can do it using the calculator. You can also look at it graphically as well. And let's go ahead and do that. Okay, so graphically, I use Desmos. If you're not familiar with this app, it's desmos.com. Great graphing utility to use. So again, remember what our limit was, as x approaches 2. So where is 2? Well, 1, 2 is right here. So again, as we're coming from the left, you can see what's happening at 2. Ooh, notice at 2, it's undefined. Interesting. But as we get close to 2, so look, as we're coming from the left, as I get close to 2, again, we're getting close to that 0.8, and I can come from the right, and again, we're getting close to 0.8, but and we know this, see, it's kind of hard to tell from the graph if you did not know, because it doesn't show you that hole, that it's undefined at 2, but we know that from our function that we were giving, because if I put 2 in, I get 0 in the denominator, and it becomes undefined. Okay, so there's 3 ways we're looking at it graphically here, using the calculator, and then using or looking at it out. Okay, let's look at another problem, and again, we'll use the calculator. You could also graph these. I would suggest trying that out. Use the given values to set up a table to evaluate the limits. Round your solutions to 8 decimal places. So again, you can plug these into your calculator, as the limit of sine 2x over x as x approaches 0 from the left and from the right. And you can see our values. What are they getting close to? As we come from the left, as we come from the right, they're getting close to 2. So again, you can plug them into your calculator and calculate. You can use this using your tables, which is very nice as well. You could also graph this function and see what's happening. We know x, as x approaches 0, once it gets to 0, we have an error. All right, so let's look at the 2 types of one-sided limits. So we have a limit from the left, so let f of x be a function defined at all values in an open interval of the form c to a, so the parentheses open intervals. Let x be a real number if the values of the function f of x approach the real number L, as the values of x, where x is less than a, approaches a number a, then we say that L is a limit of f of x as x approaches a from the left. And symbolically, you would see it below. And you notice it's a little different. It has this, looks like a negative value. Well, that means we're approaching a from the left. Okay, so we're approaching a from the left. So this is a left-sided limit. So let's take a look at a picture or a graph. So we have a limit of the function f of x. Here's that function, f of x, as x approaches 6 from the left. So here's 6. And then here's our function coming from the left, and you can see it is getting close. So as we get really, really close to 6 from the left, it looks like our function value is 2 there. So again, coming from the left side, as we get to 6, it looks like we're approaching 2 as we approach 6. So as that gets smaller and smaller. Okay, what about the limit of the function as x approaches -8 from the left? So here's -8. Okay, we're approaching from the left. What happens when I get to -8? What's my f of x value? It is -6. So it looks like the limit is -6 for this particular limit. So again, we're approaching from the left. Now, that's interesting. What's my function value? If I really wanted, what would f of -8 equal? And I'm just going to throw that in there. This is open. It doesn't equal anything here because it has a hole. However, here's my dot. So f of -8, the function value would be -3 if we needed to know the function value. All right, what about the limit from the right? And we'll get more at the importance of the function value as well. So again, this is very similar to what we were talking about from the left, except we're approaching from the right. We're going to let L be a real number if the values of the function f of x approach the real number L as the values of x, where x is greater than a, approach the number a. Then we say the L is the limit of f of x as x approaches a from the right. So again, from the right. And this is what it would look. And you'll notice there's a plus here. So that means it's approaching only from the right. If there's nothing here, we're looking at both sides of the limit, left and right. So let's look at this again. So now we're approaching 6 from the right side at this time. So from the right, what happens when I get to 6? My function value is 5. So it's not the same as it was approaching from the left. It's a different function value coming from the right. The limit is. So the limit is 5 here. All right, what about approaching -8 from the right? So let's go to -8 from the right. So I'm coming from the right, and it is still -6. So the limit of the function value is -6 as x approaches -8 from the right. All right, let's go a little further. Relating the one-sided and two-sided limits. So let f of x be a function defined at all values in an open interval containing a, with the possible exception of a itself, and let L be a real number. Then, the limit of f of x as x approaches a equals L, if and only if the limit of f of x as x approaches a from the left is L, and the limit of the function as x approaches a from the right is L. So the left-handed limit and the right-handed limit has to be equal in order for the limit to exist. So let's look at our function here. Is the limit as x approaches 6, and there's no plus or minus, so this is from the left and right, does it equal 5? Is that true? Well, let's look at that. Remember, from the left, our limit, our L, was 2. From the right, it was 5. Well, are those two equal to each other? And you would say, no, they are not. Because the limit from the left is 2. The limit from the right is 5. These two have to be equal in order for the limit to exist. So the limit of the function from the left and right, so the limit from both sides, does not exist because they have to be equal in order for the limit to exist.